All right, this is Module 5, the mid-module assessment review. We're going to go through each question, make sure you know how to do everything before that test. All right, number 1, Joel has a bowl containing 4 red, 2 orange, 4 yellow, and 10 green mints. What is the simple probability of the mint being orange? So we're going to do probability of orange. So you have to ask yourself, how many orange are there? There's 2. And the total amount is 20. That reduces to 1/10. All right, number 2, Mark placed 6 blue, 4 red in a container. He drew a tile, recorded its color, and replaced it in the container before drawing another. Suppose Mark does this 50 times. How many times should you expect to draw a red tile? Now, before we can do this, we have to know what percentage of red tiles are in the bag. So in this case, there's 4 out of 10, which is 40%. So 40% of the tiles are red. So you would expect, if you were to draw the tiles, that you would get a red tile 40% of the time. So we're going to do part equals percent times whole to figure out what 40% of 50 is. So 40% of 50, because he does it 50 times, would be 20, which is choice C. All right, number 3, 5 appetizers, 6 main dishes, and 2 desserts. How many different combinations can he make? So we're talking about appetizers, main dish, and dessert. 5 appetizers, 6 main dishes, 2 desserts. Multiply them together, and you get 60. All right, next example. So Leanne collects data throughout the basketball season and uses this data to determine the probabilities of different teams playing in the league championship game. So the probabilities for her favorite teams playing in the championship game are shown below. Which is least likely? Now, I like to change these to percentages. It's a little bit easier if you're comparing percentages. So like 1/2 is 50%, 2/3 is 67%, 4/5 is 80%, 3/8 is 38%. So which one is the least likely? That would be the Bulldogs, with only 38% chance of making it. All right, which event is most likely? So flipping a coin with sides labeled heads and tails and the coin landing on tails, well, that would be a 1/2 chance or 50% chance. Choosing a marble out of a bag with 9 blue, 1 red, and the marble being red. So that would be 1 out of 10, which is only a 10% chance. Rolling a fair number cube with faces labeled 1 through 6, landing on a number less than 6. That'd be 5 out of 6, which is 83%. Spinning an arrow on a spinner with 4 equal sections labeled 1 to 4 and a number landing greater than 1. So 3 out of 4 numbers are greater than 1, which is a 75% chance. So the one that's most likely to occur would be C. All right, the next one, it is telling us to find the probabilities of each situation. It wants to know the fraction, decimals, and percents. It says a bag contains 30 total marbles, 7 orange, 6 blue, 14 yellow, and 3 purple. So what is the probability that the marble is going to be purple? So up above, it says there are 3 purple out of 30 marbles. Now make sure you reduce that to 1/10. If you change that to a decimal by dividing, you get 0.10 or just 0.1, and the percentage would be 10%. Probability of blue, there's 6 out of 30. Now that reduces to 1/5. As a decimal, that's 0.20. You can get that by dividing 1 by 5, and that would be 20%. Probability of orange or blue. Well, how many are orange or blue? If you add them up, there's 13 out of the 30. So 13 divided by 30 to give us the decimal is 0.43 repeating. Move the decimal place over twice, and you get this, but we all know that 1/3 is the same thing as 0.3 repeating, so you could write either one of those answers. All right, not purple. So how many are not purple? Well, there are 17 out of the 30. Oh, I'm sorry, I subtracted that wrong. Let's try that again. 27 out of the 30 that are not purple. So 27 divided by 30. This fraction actually reduces. Let's divide by 3, and you get 9/10, which is 0.90 or 90%. Our probability of getting a white one, well, there's no white ones out of the 30. So that would be 0 or 0%. What is the probability that you're going to get a marble? Well, they're all marbles. So 30 out of 30 are marbles, which is 1 or 100%. So you will always get a marble when you draw. All right, number 7. It says draw a tree diagram to show the sample space. So we're ordering ice cream with toppings. You can have one flavor, either chocolate, vanilla, or strawberry, and one topping, sprinkles or peanuts. So we're going to do the flavor first. So chocolate, vanilla, or strawberry. And the next one is going to be your toppings. So you can do sprinkles or peanuts, sprinkles or peanuts, sprinkles or peanuts. Now we have to show our outcomes. You have to make a list of your outcomes. That's the whole purpose of a tree diagram. So you could have chocolate with sprinkles, chocolate with peanuts, vanilla with sprinkles, vanilla with peanuts, strawberry with sprinkles, or strawberry with peanuts. So there are 6 outcomes. So what is the probability that they will select a vanilla with sprinkles? So probability of vanilla, comma, sprinkles. There is one choice that's vanilla sprinkles out of the 6 total outcomes. All right, number 8. So they give us a chart that shows a class of 28 students and how many siblings they have. We are going to answer the questions based on this chart. So based on this data, estimate the probability that randomly selecting a student from this class is an only child. Only child means they have no siblings. So we're going to do probability of only child. There's 4 out of the 28 total people with no siblings. That reduces to 1/7. I would suggest leaving it as a fraction because it does not say to round anywhere. And if you choose to make it a percent, you'd have to have all the numbers there because you do not want to round if it does not say to. All right, what is the probability that the student will have 3 or more? So 3 or more means 3, 4, 5, and 6. There's 6 total students out of the 28. Now that reduces, you can divide it by 2, so it's 3 out of 14. What is the probability that they have less than 3? So probability of less than 3. So less than 3 would mean 0, 1, and 2. So if you add those up, you get 22 out of the 28. Now you can reduce that fraction to 11 out of 14. All right, part D. What is the probability that we select a student that does not have 2 siblings? So not 2. You can either add up 0, 1, 3, 4, 5, or 6, or you know that they all add up to 1. So we're going to subtract that from the probability of getting 2, which was 6 out of 28. So if we do that, we get 22 out of 28, which is 11/14. All right, number 9. All right, so this is a dartboard. It has 20 wedges. So each wedge represents the number of points that you're going to earn when you throw the dart. It says if you are equally likely to land in any wedge, what is the probability that you will score 19 points? So the probability of getting 19, there's one that's 19, one wedge that's 19 out of 20 different wedges. If you are equally likely to land in any wedge, what is the probability that you will land in the lower right? Now it tells you which ones are in the lower right. 3, 17, 2, 15, and 10. So that's 5 sections that are in the lower right out of the 20, and 5 out of 20 is 1/4. Now the next question says, below are the results for 100 throws for one player. So here's like the wedge number, 1, 2, 3, those are like the points. And this is how many times they landed in each one of those wedges. It says, does this player appear to have a tendency to land in the lower right more often than we would expect, less often than we would expect, or exactly what we would expect? So we already found the probability, what we think should happen. Now, 1/4 is 25%. That means that we should land there about 25% of the time. Now, let's see how many times he actually landed in those sections. So the sections are 3, 17, 2, 15, and 10. So all I did was I circled the sections. Remember, the sections are listed up top. So section 2, 3, 10, 15, and 17. And the numbers on the bottom are how many times he landed in each of those. So I'm going to add those up. 9, 2, 7, 5, and 4. Let me do that real quick. 9, 2, 7, 5, 4. We have 27 times. Now, that is 27. Actually, I'm not going to put the percent signs there. That's 27 times he landed in that. Now, he threw it 100 times. So 27 out of 100 is 27% of the time. We expected him to be 25% of the time, but he threw 27% of the time, which means that he threw more often than we would expect. You can just say 27% is more than 25%. All right, number 10. A bag contains 2 black, 6 white, and 2 red. Faces of a die show the numbers 1 through 6. Find the probability of drawing a white and tossing a 2. Now, these have no effect on each other, so they are independent probability. So there are 6 white marbles in the bag out of a total 10. We're going to multiply that by 1, 2 on the die out of 6. I'm going to cross cancel those, and I have a 1 out of 10 chance of getting a white with a 2. All right, 3 oranges, 6 bananas, 4 apples, and a fruit basket. She selects a piece of fruit at random, and then another person selects a piece of fruit at random. Find the probability that 2 bananas. So banana, banana. Now this is dependent probability because the second pick is going to depend on what we get the first time. So the first time, the chance of getting a banana is 6 out of 13. Now we're going to assume that we picked a banana. So the second time is going to be a 5 out of 12 chance of getting a banana. And now just multiply. I'm going to cross cancel first. So I get 5 out of 26 chance. All right, last question. The student purchases a bag of 24 mini chocolate chip cookies, and after opening the bag finds 2 cookies that does not contain any chocolate chips. The student wonders how unlikely it is to randomly find a cookie with no chocolate chips for this brand. So based on the bag of 24 cookies, what is the probability with no chocolate chips? So no chocolate chips. Well, in this case, they found 2 out of the 24 were no chocolate chip, which reduces to 1 out of 12. So that's the probability right now. Now, how could we simulate this? Because obviously we're not going to buy 100 bags of cookies, although that would be good, and check them all. But we could come up with a probability experiment that would do this for us. Now, this is not equally likely probability. So the best method for this would be putting colored chips in a bag. So there are 2 outcomes. And you can say with chocolate chips and no chocolate chips. So since there are 24 total cookies in the bag, we're going to place 24 chips or cubes in a bag. Now we have to designate 2 colors, one to represent the chocolate chips and one no chocolate chips. So let's do 2 white would equal no chocolate chips, which means there are 22 black, which would represent the chocolate chips. Now, what are we going to do to represent this experiment? We're going to pick out a cube, record, and put the cube back. Doesn't say how many times we have to do this, so you're just going to keep repeating. And that's your whole test. So go ahead and study that review sheet, and you should be prepared for this test, the mid-module assessment for Module 5. Good luck.